To solve by factoring, you multiply the first number times the last number and you write down the factors of 36. To find the pair that's going to add up to equal negative 13, which pair is going to add up to equal negative 13? If I put the negative signs in that way, I'm going to work it the long way just to kind of refresh your memory. In place of this, I'm going to put a negative 4x and a negative 9x. Still have the x squared in front, still have the 36 in the back. Working it out the long way. The long way, you make two groups of 2. The GCF here is x. The GCF here is negative 9. Just coming back to your memory. Factor out the GCF here, and you get x minus 4. Factor out the GCF here, you get x minus 4. I have a double factor of x minus 4. So I factor out the x minus 4. This is not solved. This is factored. It's not solved. It still has another step. Either, remember, the other name for solving is the one that starts with a Z? Zeros. Because that's how you solve it. You put it equal to 0. And then you solve both of these little equations. I'm running out of room. I'll put the answers over here. X equals 4. You're going to add 4 to both sides. You're going to add 9 to both sides. And those are my two solutions. You have two solutions because if you graphed it, you would have two x-intercepts. Those are the x-intercepts, they're the zeros, they're solutions, they're roots. Okay, the next problem. Before I solve that one, do you see that, did I mistype it? It is x. Is that what it is on your paper? Okay, and do you see that it has a GCF that I can factor out? What is the GCF that I can factor out? Not just 2, but 2x. So if I factor 2x out of that, and 2x out of that, and 2x out of that, and then, if I multiply the first number times the last number, what are the factors of negative 14? Would those pair of numbers add up to the 5? And I'm going to do this with a shortcut this time. Because this is a coefficient of 1, I can use the shortcut. Now, this equation was not quadratic because what power is that? So there should be 3 answers, and either the first term equals 0, or the second term equals 0, or the last term equals 0. And so this one has 3 answers. It would have 3 x-intercepts, and we'll be learning how to graph that one coming up next semester. But that one has 3 answers because x is to the 3rd power. There's one more problem I want you to factor and solve. Would you please add this? You're going to add it, put it on the back of your notes because I don't think it'll fit on this paper. How do you factor and solve this one? Do you remember that if it is missing the b, you can put it in like that? And so if you multiply the first and last number, what pair would you use to zero out? And so this would be using the shortcut x minus 5, x plus 5 equals 0. It's called zeros because it's equal to a 0. And it's going to have 2 x intercepts. But there is another way to solve that one that I wanted to talk about that's going to lead into our lesson today. You can also solve this one by adding 25 to both sides, isolating the x. I need to solve for x. In order to solve for x, I need to get rid of the square. How do you get rid of a square? What's the opposite of a square? Can I take the square root of both sides? The square and the square root cancel each other out, so this is equal to x. What's the square root of 25? Why is it 5? 5 times 5 is equal to 25. But this is quadratic. How many answers are there supposed to be? 2. Where's the other answer? Well, what is negative 5 times negative 5? Isn't that also equal to 25? Now, in the past, we have ignored this answer because most of the square root problems you've done in the past were to solve the Pythagorean theorem. Remember the Pythagorean theorem? When did you use the Pythagorean theorem? What class? Wasn't that geometry? Oh, come on. You remember the Pythagorean theorem. We did it till you were sick of it. Okay, Pythagorean theorem. What were you solving? What shape does the Pythagorean theorem go with? Triangle. And when you were solving the Pythagorean theorem, you were finding the side of a triangle. Can the side of a triangle be negative? No, that doesn't make sense. So we just kind of ignored this answer because it didn't make sense for triangles. But now the problems we're doing are parabolas. Can parabolas have a negative x-intercept? So we can't ignore this anymore. When you take a square root to solve an equation, there is a positive root and there is a negative root. And so there are 2 answers when you take the square root. The reason you ignored this other answer previously is because it just didn't make sense for triangles, so we just ignored it. But we can't ignore it anymore because it does make sense for parabolas. Now, before we go on, we need to look at these problems that you multiplied out and we're looking for a pattern. Who had x plus 1 squared? Who had that as your box problem? And what was your answer? Anybody else have that one? Did you get the same problem? Okay, x plus 2 squared. Who had that one? What did you get for your answer? Did anybody else have that one? You got the same thing. X plus 3 squared. Who else had it? You got that same answer. X plus 4 squared. Who had that one? What'd you get? Somebody else have it? You get the same thing? X plus 5 squared. Who had that one? What'd you get? You get that also? Now, do you see a pattern? Please look at example number 1 in your notes. How do you use this pattern to complete the square? Now, who had the x squared plus 8x as part of your pattern? Was the 20 the right number there to complete the square? The 20 is not the right number. And so the first thing we're going to have to do is add 20 to both sides to move the 20 out of the way so we can complete the square with the right number. What was the right number at the end of your pattern? This number right here was 16. If I add a 16 on this side, what do I have to do on that side? How can I calculate the 16? This is in standard form. What's the B number? And so to get this 16, you do 8 divided by 2 and then square it. What's 8 divided by 2? So that's 4 squared, and 4 squared is equal to 16. That's where the 16 came from. In case she's not sitting over there on the side of the room and I say, well, what was your number? You have to be able to figure that number out for yourself. Now, this is equal to x plus 4 squared. And I usually get the question at this point, where did the 8 go? Well, if I multiplied this out with a box problem, wouldn't it be equal to that? This and this are equal. If I multiplied it out, I'm doing like the box problem backwards. And so over here, this is a 36. Okay. I did all that. Now, why did I do all of that? Because you can solve it from this format. If I take the square root of both sides, the square and the square root cancel each other out, and this is x plus 4 equals the square root of 36. What's the square root of 36? But I'm supposed to have two answers. Where does the other answer come from? Well, the square root can also equal to negative 6. The square root equals to positive 6, and it also equals to negative 6, because negative 6 times negative 6 also equals 36. Subtract 4 from both sides, and x equals 2. There's one of your answers. Subtract 4 from both sides, and x equals negative 10. Why is this not? There's your second answer. X equals 2 and x equals negative 10. When you solve a quadratic equation, almost always there's two answers because there's two x-intercepts, usually. Example number 2. When you solve by factoring, when you solve by the quadratic formula, it has to be equal to 0. When you solve by completing the square, it does not have to be equal to 0. It's equal to some other number because I've got to subtract this number out of the way. Got to subtract that C number so I can force it to be in the correct form. Now I'm going to leave a space here, and that's going to equal to negative 11. This space here that I skipped is so that I can force it to be in this perfect square pattern. Negative 12 divided by 2 and square it. What's negative 12 divided by 2? Negative 6. What is negative 6 squared? Positive 36. This number will always be a positive number. I don't care what your calculator tells you. If you put it in wrong, the calculator will tell you the wrong side. The reason I do this is to change it into this completed square pattern. what number's going to go here? And if this is negative, this will be negative. Well, where did you come up with the 6? Well, there's two ways to come up with a 6. What's half of 12? Well, it's the square root of 36. So either way, you're coming up with the 6. This is using the pattern we started the class with. The reason we do that is so we can take the square root of both sides so that the square and the square root can cancel each other out. What is the square root of 25? Or negative 5. There's two answers. The square root is positive 25. The square root is negative 25. And so then I solve it and get two answers. There are two x-intercepts to a parabola usually. How could I possibly only get one answer? Sometimes there is only one x-intercept. I'll let you think about it. How could you come up with just one answer? Next example. To factor. To use the quadratic formula, it has to be equal to 0. But when you're using the complete the square, I don't want it equal to 0. I want this number out of the way. X squared plus 20x, leave a space. What goes in that space? Over here, 20 divided by 2 and square it. What's 20 divided by 2 and square it? If I add 100 on this side, what do I have to do on the other side? I have to add 100 to both sides. The reason I added the 100 is this is equal to this perfect square pattern. Where did I get the 10? 20 divided by 2. If this is positive, this will be positive. And this one over here will be 121. The reason I did this was so right here in this step, I could take the square root of both sides to cancel out the square and the square root cancel each other out. So this is x plus 10 equals what? What's the square root of 121? And x plus 10 equals negative 11. Subtract 10 from both sides. There are two answers because you will have two x-intercepts when you solve a quadratic. How did you do on problem number 1 on your homework paper? It would not matter which one you put first. If you have a positive 15 and a negative 1, it doesn't matter which order that you write them down in. Did you find your two x-intercepts? How did you do on problem number 2? Problem number 2 is on the left-hand side of the page. It goes 1, 2, 3 down the left-hand side of the page. Did you get problem number 2 correct? And so this worksheet will be due on Wednesday.